Hello, everyone. A warm welcome from Singapore, and thank you for joining our today's webinar, which will be focused on on-site adjustments. So let's jump into it. Firstly, let me please introduce ourselves. So my name is Jan. I'm Regional Director at IDEA StatiCa Asia and Pacific, and I have my colleague Stefano, product engineer, here with me, and he will show you how you can deal with all these tricky situations which may happen on site. Just for you who are new here or it's your first webinar, please feel free to ask, comment, put any suggestions, whatever comes to your mind to the question tab. We will try to react during the webinar. At the end of the webinar, we will answer some of the questions, and the remaining questions we will answer after the webinar. So we are happy to hear your thoughts and comments, so please use this. Actually, what is this topic about? As I mentioned at the beginning, it's about on-site adjustments. So I'm structural engineer, my background is structural engineering, Stefano's background is structural engineering, and we have faced quite often with these situations. There might be misaligned holes in the steel parts. There might be wrongly installed anchors. We were facing also collisions with other elements or concrete slabs. Sometimes the guys on site made some notches and cuts, and then they want us to confirm that it's okay. Or also what happens quite often is that in our calculation, we take into account some edge distance for anchoring, and then there is some error on site, and the concrete is not cast in the proper place, and then the distance is smaller and the check fails. So those are the situations I faced during my career. Please feel to write comments if there is anything else you are facing. I can try to explain if IDEA StatiCa can help you with that. And what are the issues if we need to resolve this? Like from my experience, typically if someone writes me an email like, hey, we need your help to resolve this situation, or they give me a call, typically I'm in the middle of something different. I've already finished the project, and now I have a new deadline. Now, out of nothing, I need to deal with a new issue. So I'm under time pressure. Also, I typically cannot use my software. So if I used my Excel spreadsheet, probably I cannot do those adjustments to check the new situation. Also, yes, there are some solutions that can be quite expensive. So I could propose, okay, I don't care, just you need to fabricate a new piece, but it can be really expensive. It can cause big delays on site, and we are partners with site, so we want to find the best solution for them as well. And also what can happen, and it also happened, sometimes it could be my mistake. So I have something wrongly specified or submitted a wrong drawing. So yes, I need to find the best solution because then I can save myself. So before proceeding to showing you those examples, how they can be easily resolved, I would like to ask you in our poll, how often do you need to deal with on-site changes? So let me please run the poll, and please answer these questions if this situation is happening to you very often, or just sometimes, or rarely. So we will see, like, okay, I just see some results. I would ask the remaining attendees to vote. It's about 50% have voted. Okay. So I will give you 5 more seconds. And okay, let me close the poll and let's see the results. So I would say vast majority is facing this situation often or sometimes. Okay, so then it seems that it's good to have a tool how to resolve them quickly and efficiently. So thank you very much for this. I will hide the results, and now I will pass the presentation to Stefano, and he will show you how you can deal with this situation easily. So Steph, is yours now.
Okay, thank you, Jan. Let me try sharing my screen. Right. Okay, so give me 1 second. Okay, thank you. Yeah, so I prepared some study case today for us to look into it and see if IDEA StatiCa can really help you on those cases that you find during your work. Okay, so the first case that I prepared today is this type of a connection to baseplate with some diagonal members. So let's say you have designed this nicely, you have submitted it, and now the plate is already manufactured. Everything is ready to be installed on site. But then you might see that on site there are some unplanned interferences preventing your bolt installation. For example, something like this is a real photo from a project. You will see that there are only 5 bolts that can be installed in your connection. Now, what can you do? You can, change your design, maybe go to your Excel, but how do you consider like the bolts opening that is already manufactured inside your plate? Then how do you consider like the non-symmetry of the bolt arrangement that you see here? It might be a headache for you, but if you're using our software, you don't need to worry about it. I'm just going to open up IDEA StatiCa. Okay, so for this case, for example, this design has been done quite a few years ago, then you don't have the original connection file, or maybe you were using Excel or something before that. No worries, I'll just start from a blank. So firstly, you must model in your geometry with the right cross sections. Then you put in your forces. After that, you put in your original geometry first by using this operation tab here, top. Then firstly, I'm going to model in the base plate. Then I'm going to adjust the geometry. To profile and then you change the anchoring length based on what you have designed previously, and also the position of the actual anchors itself. And 40. Then change the offset, change this one to friction. Okay, now I've taken care of my base plate. Now I want to model in the connection of my diagonal members using this so-called connecting plate. So first you change the member that you want to connect. Then you want to relate it also to the base plate, because this connecting plate is related to both this member and the base plate, column and the base plate. Then you also need to change the geometry based on what you have manufactured. Change the capping plate and the geometry of the capping plate and the thickness of it. Same with the bolt. Yeah, you can change it as per what you have constructed on site. Say. Then yeah. For this one, yep. Okay, so basically you can just model in what you already have, like what you have on site. You can also, let's say, change the bolt material, bolt geometry, bolt diameter based on what you have on site. You can also, let's say, you can also create your own import, change your own section based on what you have on site. You can even modify or custom your shape based on what you have on site. So it's very flexible. And even in the material tab, let's say you are not using the standard materials, you can also customize this very freely. Okay, so I have finished, but as you can see here, there are some warning here. no worries, we can just go to transparent view, and then we can find where the problem is. So you can see here that my plate is going through my profile, diagonal profile here. So I'm going to do is to put some cuts here by going to editor, going to gusset. I want to change to add some of the bevel. Change the sizes, adjust the corner accordingly. And then I add another bevel. You just need to click apply. Now you see that all the clashes warning is now gone, and you can see in the transparent view there's no more red color, means there's no clashes in your model. So once you model your original connection design, you can actually just run it to check whether your design is working or not. Let me check. Connection plate 2P145. Okay. Let me see what is wrong here. Both are too close to. Let's just run it again. See. Okay, now good. So you can confirm that your original or your first design is working correctly. Now you want to adjust it to what you actually have on site. So I mentioned just now we can only construct this 5 bolts. We cannot install these 3 bolts. So what you need to do, you need to remove that bolt by going to this plate editor here. We go to editor, we go to tongue, and then we just explode the bolt. Then we want to remove this 1, 5, and 6. That's it. Now you click OK. You can see the bolt is now gone for the one that you cannot install, but then you still need to put in the holes to mimic the actual geometry on site. So you go to editor again, go to tongue, then you just need to add holes for those bolt holes that you have just removed. Right. Then the diameter should be 2 millimeter plus your bolt diameter, which is 14. And you just need to copy it, then put it for the bolt that you have just removed. So that's it. Just click apply. You can see there's a hole now in our tongue plate, but there's no hole yet to this connecting plate here. You just need to go to editor again, then click the gusset plate. Then we need to add the same holes here. Okay, once you are satisfied with the position, just click apply, and then you can check whether your model has the correct hole position or not. And you can see now that it already has the correct hole position, and that the geometry is now matching on what we have on site. So now we don't need to worry whether it can work or not. We just need to click calculate and check whether your connection is really working with the given load or not. Right, so you finish running, you can see here that we have all ticks here, meaning that our current on-site design is working. So yeah, you can remove just these 3 bolts and left the hole there, and now your connection is still working as intended. If you want to see more detail, you can go to check tab here. You can see all the the bolt forces, the anchor stresses, the weld stresses, then the concrete block stresses, all that. Yep, you can check all this very detailed report here, and of course you can also check the equivalent stresses of your plate lah. Once you are satisfied with everything, you can go to report. Then you just need to click a general report. And that's it. You can use this to justify whether your on-site connection can work or not. Then you can submit this and then go on with your day. So that's the first example. Now let's see the second case study. Right. So the second one, let's say you have design your base plate, put in your bolt, check your bolt and everything, but then when it comes to site, when they're trying to install it, the anchor is actually misaligned. So you have manufactured your plate, you have installed the anchor to your concrete, then you have casted your concrete, and then when it comes to installing the plate, then it's actually misaligned then your hole with your bolt hole. Then there's also some cases where maybe we have some manufacturing defects here. As you can see here, there are some holes to the plate that was not planned. But same as before, you don't need to worry if you are using our software. You just need to open our software and model all these holes and all these openings as per what you have on site, and check whether the connection still can work or not. So I'm going to do that now. Going to the second case. Okay, for this one, let's say you are using IDEA StatiCa, you still have the original connection model. So what you need to do now, you just need to modify this model by going to. Okay, the first thing that I'm going to do is I'm going to move the bolt and then add the misaligned holes. What you do, you can go to editor, can export it, and you can move the bolt to the current location. Right, so I'm doing now. 5 minus 225, then this one also is minus 225. Okay, once you're satisfied with the new location of your bolt, just click OK. Then we also need to add holes which is misaligned but already manufactured. Just put in our original position. Oops, -1. The diameter, of course, you need to adjust it as per your bolt hole. 95, 1.5, 3. For the last one. Okay, then we just need to click apply. Okay, so as you can see here, we have successfully modeled the misaligned base plate, and we can also model the hole very easily. Then left one thing, I want to model in the misaligned holes manufacturing defect that we can see here. For that, you can use the same thing by going to editor here, and I just put another circle hole with adjusted position, and adjusted diameter. That's it. So click apply. Now you can see that the even the manufacturing defect you can easily model inside IDEA StatiCa. After that, you just need to calculate and confirm that your current connection is still working. You go to a check tab here. You can check that the stresses of your plates. Yeah. And you can see the stresses inside the concrete, how the manufacturing defects and how the misaligned bolt affect your concrete stresses and all that. You can also show the deform shape if you would like to, so that you can confirm that everything is still okay. Right, so that's my second study case. Now let's jump on to our case number 3. So for this one, you have already designed your connection, same as previously. But after you manufacture the plate, you manufacture the beam offsite, you have put all the bolt holes in there. When it comes to installation of the beam, you see here that the manufactured beam holes and plate holes is misaligned. Right, so I'm going to go to software IDEA StatiCa here. So for this case, yeah, I have a pre-prepared model. Let's say this is your original design intent. We just run it first and check everything is working. Right, so everything is working correctly for the original model. But then, yeah, what do we do if we have something like this? We have a misaligned hole like this. The solution will be just to not use the bolt anymore, but we can just use a weld all around this fin plate instead. So to check the new solution, yeah, you can easily do it using IDEA StatiCa. Firstly, you want to remove the bolt first by going to editor and then explode and delete all the bolts here. Then I want to simulate the actual geometry by putting in all the bolt hole which already manufactured there. Go as the position, copy it, and E 0, 0, then a minus 60, and minus 120. Then you just need to click apply. Yep, as you can see now the bolt hole is already put inside as per what we already manufactured. Now we just need to put a hole to our beam web. Now to do that, you can use our opening operation. You just put it in and then you select the web, the beam. And then you change the diameter accordingly to our bolt size. And of course, you need to change the position accordingly. Right. Next position is not correct. Right. So as you can see, you can use this opening operation to actually simulate the bolt opening that you have manufactured to your beam of the web. Web of the beam, sorry. Then I just need to copy this and change the eccentricity here. Is the location. Right. Oops, what is this? The intersection. Oh, okay. Minus 120, minus 60, 0. Let me check. This one is causing problem. Copy. Minus 60. Okay, sorry. So we have minus 60 on top. So now it's 60 and 120 on the bottom. Right. So once you are satisfied with the bolt hole and you think now is that matching already match of what you have on site, now it's just left to put the weld around the fin plate and connect the fin plate with the beam web. we're going to go to operation and add a weld operation here. Then we need to change the second plate to beam weld. Right. Then you can see here some small numbers here, 1, 2, 3. 1, 2, 3 is actually the edges that you want to weld between these two plates. So I'm going to make this a C-shaped weld here. So I'm going to use index 1, 2, and 3. Then I just need to change the weld thickness as per what is required. So that's it. We just need to click calculate. And you can see in just about 2 minutes, I can actually confirm whether my design can work or not. So yeah, you can see it's very easy to play around with your design, iterate all solutions that you have in mind and see which one works best for your connection. So we have solved our case number 3. Now let's move on to case number 4. Okay, so for this case, let's say you have finished, not you, maybe there's a building that have designed for in the past, let's say maybe 10 years ago or so. Then the owner of the building wants to, change the usage of the building. Then by doing change in the usage of the building, there'll be an increase in our forces to our connection design here. So there are multiple reasons that the increase in load might happen. As I mentioned, maybe change in usage, change in framing, maybe removals of some column and beams, and of course it will increase the load to your connection here, and maybe some building expansion. So what do you need to do after this? You need to modify your global FEM, and then you need to check whether your member is still okay or not in your global FEM. Once you confirm that your member is okay, you need to move on to confirm whether your existing connection can work with the increase in this load. Right. So I'm going to open my IDEA StatiCa here. Right. For this one, because most probably someone else will be doing the design a long time ago, so you would not have the connection model. So I'm just going to start from a blank model. I'm going to show you the template that we have inside our software here by clicking this propose button. Right, so what does our template do? Actually, it will detect the geometry of your connection, and then it will suggest all the connection that is appropriate for the geometry that you have modeled in. Right, so I'm just going to see whether our on-site connection has something similar here that I can use. Okay, maybe this oversized end plate is good enough and can match what we have on-site. So you just click OK here. You can change the steel grade and bolt grade accordingly, but I'm not going to do that. Just going to click OK, and you can see with that 2 clicks, you can actually model the whole connection easily using our templates. But then I still need to adjust a little bit according to what I have on site. Right, just change the bolt grade, and I change the size of the weld. As I mentioned, if you have some, because it was designed maybe a long time ago, maybe you don't have your bolt grade here, you can actually customize it very easily here. Same goes for your steel members. Maybe, yeah, you are using some material which is not currently not used anymore. You can just go here and custom your material freely. Right, once you finish, then we have our original load here before the changes in, let's say, building usage. So this is our original load. I'm just going to run it and see whether everything is working correctly or not. So as you can see, you have confirmed that the current design can work for the current load. Now we want to check whether with the new load, that our connection still can work or not. So I'm going to increase the bending moment from 55 to 65 and added some more shear, 20 to minus 30. Then I need to change, all these so-called reaction load from this so that I can get the balance force in my node. This one, 60 and here minus 30. As you can see now, my node is balanced. You can confirm it by looking at this unbalanced force table, and you looked at everything now is 0. Right, I'm not going to change my design now. I'm just going to check whether what I have on site now it can work with the increase in load or not. Okay, now you can see that actually this plate is not working. You can go to check tab, and so this plate and these bolts are not working. Go to check tab. So what I like to do, I like to on this plastic strain and see the deform shape. You can see that, yeah, this plate is working hard, but there's also this panel zone is also working hard, if you see here. So so we're going to think what we need to do here. I'm seeing some panel zone working hard here. So maybe the first iteration, maybe I just strengthen the panel zone here. So what I'm going to do, I'm going to use operation, use this stiffening plate, and I'm going to change the position to member, change it to C, and web 1, change the type to doubler, and the location to both. So both indicates that it's in front and back. I'm going to change the thickness and the geometry of my doubler plate. Right, so well, yeah, I'm thinking, okay, maybe this one can work to strengthen our panel zone. Just click calculate again. Oops, okay, so the panel zone now works, but then this plate is also works, but then still there's a failure in this beam. Okay, then what do I need to do next? I'm thinking to add some kind of seated connection, seated plate here to actually strengthen this connection. I'm going to use operation again. Now I'm just going to put a rib connection and change the thickness, geometry, change the shape to chamfered, and change the position to bottom flange. Surface lower, the position is center. So I want to add some seated connection like that. Seated plate. But then you can see here that there's some plate clash warning. Same as before, you see a clash warning, you just need to go to a transparent view. You see a red color. Red color indicates where your clashes is. Right, so I need to add some kind of plate cut here. You can do that by going to editor, and I will add some notches. Selected corners number 5 and change the geometry. Apply. And you can see now that the plate clash warning is now gone. And let's just quick calculate. Right, as you can see here, there's still a bit of failure here. I'm going to, click this one, change the value to, let's say 5, make it a little bit bigger. Let's click calculate again. Right, now as you can see here, there are 4 number of ticks, means your connection is working. So it's now all good. But then I see the panel zone seems like not working, because you see the traffic light here. The traffic light colors here indicating that gray color is not so much used or underutilized, whereas green is optimal. So I'm thinking maybe this panel zone is not really needed once you added this seated plate here. So I'm just going to turn this operation off and remove the double plate on the panel zone of the column. Then I just click calculate again. Right, now you can see that it can even work well without the double plate. So yeah, I'm satisfied with my final design. I was able to try out several different solutions quite easily here, iterate through them, let's say double plate and then the seated plate. Then I can find the most optimum solution for my connection here. So once I'm satisfied, same as before, I can go to report, generate report. Yeah, and then you can use this to submit and justify your strengthening of your current connection design. That's it for my case number 4. Now the last case that I have here is, for example, you have already satisfied your base plate design here. This is a base plate connected to some sort of slab. But then when it comes to construction, you might see that your concrete slab is not casted in the correct location, which means now your edge distance of your anchors is now become much smaller than what it is. Then you use IDEA StatiCa to check whether the edge distance is okay, but then you see that there's an anchorage failure due to lesser of the edge distance. So what you do here, you don't need to worry, because we have our concrete module whereby you can actually model in the slab reinforcement which you have casted. You can have we have this link between our connection application and our concrete application, so all your forces from the base plate will be transferred automatically, and all the geometry of the base plate will be transferred automatically as well. And you just need to model in your reinforcement. You just need to click run, see whether your anchor still fails or not. But we found out here that with the rebar, we're considering the rebar inside the slab, you can see that the anchorage actually is fine, and it can work as per what it is designed for. So you don't need to worry, you just need to then submit this justification, and yeah, you can go on with other design. Right, so that's now from me. Going to hand it back over to Jan.
Thanks, Stefano. Let me show my screen. So thank you for showing all these examples. So in a small summary, actually, we haven't shown the last example much in detail because this is something pretty new, and we currently support only Eurocode, but in a version coming in less than 1 month, there will be also ACI included, and we will do a separate webinar for this, very likely. So stay tuned. But overall, how IDEA StatiCa can help you right now? You can actually quickly assess if the adjusted connection is okay. So if you are asked to do that, you may use some excuses, but you may say, okay, I will do my best, and see if all the crazy things which may happen on site can be verified. You can model the connection components as they've been manufactured. You can take into account all the effects of holes and notches. Sometimes we structural engineer may say, well, it won't have any effect if we don't include the hole there. But the client may ask, but I want to prove it. I can see on site that there is a hole, I can see the hole, and I can prove by calculation that it won't have an effect. Okay, then you can prove it. You can actually also iterate all the possible solutions of retrofitting easily. So you may check whether you should weld it from top, from bottom, where would be the most convenient way, because sometimes maybe the first proposed option may not be the best. So you can spend a little more time on finding the best solution. And ultimately, you can submit a report and prove to anyone that this side change is okay. It follows the code. It's very important. You have a proof that all these changes are still according to building code. Yeah? So I would say these are the main takeaways. What can be the benefit for you as a structural engineers? You just prove it's okay, and you have a tool for that. All right. Actually, I would like to ask you now for another poll. Let's say, how do you find IDEA StatiCa for site adjustments and retrofitting? If you found it very useful, rather useful, not very useful, or you may be honest with us and say that it's useless. Okay, thank you. Thank you for your votes. There's already 60% attendees have voted, so I will give you 10 more seconds, please. We would be very happy if you can share your feedback with us. Also, you can then comment like what you think is useful, what we should be, what are the other cases we should be able to cover, or if you don't think it's useful, then we are happy to hear why you think so. Okay, let me close the poll. Two-thirds have already voted, and let's share the results. So I'm very happy to see that 75% sees IDEA StatiCa as a very useful tool. So great to hear that. And the remaining part is like rather useful. So I'm very surprised that there is no one who has voted for not very useful or even useless. So thank you for this great feedback. Let's move on. There are some questions. Some of them answered already, but I think we can answer them also to everyone. One question is from Mr. Rahul, if it's possible to design multiple connections at a time. For example, I have a portal frame with beams in 2 different levels. Is it possible to model entire frame into the designs for connections? Yes, there's a way. Actually, the best way how to do this, if you have like the whole structure, you can use one of our beam links. So, for example, you may have a structure design in StatPro, Sub 2000, ETAPS, Midas, and other software. You can import the whole model through the application called Checkbot, and then you can select the nodes to check, and you can also do all these changes and interfaces Stefano showed you today there. Also, there is another way what you can do. We have also application called Member. If you need to model like one frame, not like the whole structure, but let's say one critical member, one frame, you can use the application Member. You can use the same approach for modeling the whole part. This is very useful, especially if you need to take into account the real stiffness of the connection, and if you are dealing with some stability issues like lateral torsional buckling, generally like the torsion of the beam. So this is also very useful. Also, okay, I'm still showing the results. Good, but no more slides. And also one more. There is also a question if in case 3 there are instances where the weld length becomes insufficient when bolts cannot be used due to misalignments. Is it always adequate to rely on welding in such cases? If there are no sufficient length of the weld, you will get a warning from detailing checks, like there will be like exclamation like the length of the weld is not okay. Yeah, so we check the length of the welds as per the code. Also, maybe one question, Steph, you can answer this. What codes are supported in IDEA StatiCa connection right now?
Yep, yeah. So we have a lot of code supported. We have Eurocode, AIC, Australian code, China, Russian. Yeah. So we have a lot of code which are used worldwide, supported in our connection application.
Thanks for the answer. Yes, so if you need to submit a report which has to follow one of those codes, currently we support 8 codes, then yes, you can select at the beginning which one needs to be, which one is relevant for you. Okay, there are some more questions coming. My beam to column moment connection, the column is failing for local buckling. I have added stiffness on web at every 500 millimeter spacing. Is it possible to add this stiffener effect to a member if we are designing only connection of beam? I would also suggest for this situation, if you need to take into account the behavior of the whole member, include some stiffeners, let's go to the member application. It's also why detail. Okay, let me check. Why detailed calculations for plate design or member design are not shown in reports. Actually, in terms of detail calculation for plates, we are checking the plastic strain limit. That's the magic of our software. So there is a table. Which shows the equivalent stress and plastic strain of each component, and you can see it in the report. Maybe Steph, if you want to show it quickly in the report.
Yep. Let me try pulling up my computer. Okay, and let me share my screen. Okay, I just show my screen here. So you go to report tab, you click generate. Yeah. You can see that there's this strain check that we have covering our design of the plates here. Maybe this one is, okay. I go to another connection, you also have this strain check. So basically our plates and our members are designed to this 5% strain, plastic strain limit here, which is based on Eurocode. But on other code, this limit of 5% plastic strain is also matches what the other code are using. For example, like AISC, if we test the limit on AISC, it will be matching to what we have as a 5% plastic strain that we've taken for Eurocode. So yeah, to answer your questions, we are using this 5% limit strain to actually check the plate and the member.
Thanks, Steph. Maybe one another question. If you're on web, can you just go to BIM page and show the links, because there are some more questions if the calculations from other structural analysis software can be used. Yes, it can, and I will show you where you can find more details.
Yes, so you can go to our website here, ideastatica.com/BIM. You can see that yeah, the list of the software that support linking to our software, IDEA StatiCa. You can select whether you want to connect your FES software, such as SUB 2000, CR, Midas, and ETAPS, or you can choose your CAD software instead. So how it works with CAD software, you model your connection, let's say in Tekla structures first, then you can import it easily to IDEA StatiCa.
Thanks for that. Also, there's a question regarding if the chemical bolts can be used and if IDEA StatiCa can verify the adequacy of these bolts. My answer is yes. The ideal tool for this is IDEA StatiCa detail in 3D, something we showed you in case study number 5. You can specify the bond strength there of the chemical anchor. So if you are using, let's say, healthy products, Fisher products, other products, they will give you this value. You can use it there and check it in detail 3D. We can show you more when we will have it localized more for this market. Now it's only Europol, but still you can find more information on the web. Okay, there are some more questions. We will answer them after the webinar because we are running out of time. So thank you very much. I'm happy to see all these questions. Feel free to ask more. Let me just change the presenter back to me. Okay. And let's go on. So also, I would like to tell you something about IDEA StatiCa Campus. For those who are already users of IDEA StatiCa and you want to deepen your knowledge, we recommend you to go to our web to ideastatica.com/campus, and you can go through our online courses. The course is for free. Only if you would have an official certificate, that there is some fee, but overall, if you just want to learn how to operate with IDEA StatiCa, we recommend this. We have the course for steel and also for the concrete. If you are not a user yet, but you like how IDEA StatiCa works and you would like to try it by yourself, so you can go again to our web page. In the top right corner, you can click on the free trial button. You will just fill some of your credentials and get a fully working version of IDEA StatiCa. So feel free to test it yourself and then to share feedback with us. I personally believe you can find a big value in our software, not only for on-site adjustments, but all the design situations which you may face during your work. Also, after the webinar, we will send you a short survey. Please fill it. Please put some notes. How do you like it? If there are any suggestions, what you would like to see next time, yes, we are happy to see that. And also, that's it for this survey. And also, we will then share a recording with you so you can go back and see all these use cases. And also, don't forget about support and learning, and you will find more information. So if you want to get a deeper understanding of whatever situation, just go there and search for that. So it's all from our side. Thank you very much, and we are looking forward to see you on another webinar. And stay tuned. As I mentioned, there will be a new release with great features within a month. So hopefully you will like it, and we will see each other on a release webinar presenting you all the news. Thank you very much. Bye-bye.